Hi yes everyone, welcome to Coast Lesson 4, where we're going to be having a look at coastal erosion. Just a quick reminder that you can pause this video at any time or go back to any of the slides that you need to. There is a task at the end, and then there'll also be a quiz on Show My Homework for you to complete after this lesson. Please only complete the quiz after the lesson. It's really important that you do that, because if you complete it before, then you're basically just guessing at the answers. So the quiz will be based on the content of this lesson, and it's used then for us as your geography teachers to check your understanding of the lesson, and we can then go over anything in future lessons that perhaps you didn't understand. So let's start Coast Lesson 4, which is looking at coastal erosion. So erosion is a term that you've already come across in Coast Lesson 1, but we'll go through it in a lot more detail. So we're going to have a look at understanding the process of erosion and how it changes the coastline over time. So erosion is an ongoing process. It's not something that happens straight away. It's a continuous process along our coastlines. So the big question is, what is erosion? So have a look at this image. What is happening? Can you explain in your own words what is happening in this image? So you can see that the road has been cut off and you can no longer drive across it, and the coastline is backing up towards the houses because of this process of erosion. So a definition for you to write down and learn. So erosion is a wearing or breaking down of material like rocks. It usually occurs when the sea takes lots of energy from the power of destructive waves. So remembering that destructive waves are the more powerful type of waves. They have the most energy, and it's erosion that requires quite a lot of energy to take place, and therefore it mainly happens through destructive waves. So you'll have seen this slide before. So 4 key factors affect the rate of erosion along the coastline, affect the speed of erosion. The first 2 link together, so rock type and rock structure. That's looking at a discordant coastline, which you can see on this image here. So you can see the headlands are the harder rock of chalk and limestone. They take more time to erode away. They're more resistant to erosion. Whereas the softer rock of clay and sand, they form the bays, and that's because they erode a lot more quickly. They don't require as much energy to erode. Then you've got the shape of the coastline. I'll just move me out of the way. So you've got the shape of the coastline. The headlands that are already created are then exposed to this full force of destructive waves. So once the headlands are formed from factors affecting rock type and rock structure, these headlands are then experiencing the full force of destructive waves, whereas the bays become more sheltered and therefore they get less wave energy. So it's actually the headlands that then start to erode at a quicker rate. And then finally, we've got the type of wave. We know that destructive waves have more energy than constructive waves, and therefore the rate of erosion is quicker through destructive waves. So there are 4 types of coastal erosion. You've got abrasion, attrition, solution, and hydraulic action. We're going to go through these 4 types. It'd be really useful if you can jot them down or make notes and also draw diagrams. So the first type is abrasion. It's also known as corrosion. So you might see it as either one of them terms, but it means the same thing. I'm going to refer to it as abrasion, but just be aware there's two names for this. So abrasion is when waves pick up sediment and they basically throw the sediment, the rock, at the cliffs. So it's like a type of ammunition, and this over time chips away at the cliffs. So imagine a wave that's created using circular motions, and that circular motion picks up some of the sediment, some of the rock from the seabed, and hurls it at the cliff, and this will chip away the cliff over time. Number 2 is hydraulic action. So hydraulic action is when water is forced into the cracks, and you can see on the image there, water is being forced into the cracks when the waves hit the shoreline and hit the cliffs, and the air becomes trapped in the cracks, and the air is compressed and pressure is built up, and then it blasts out, and that forces the rock apart. So it's the force of the waves pushing air into the cracks that causes this type of erosion. The third type is called attrition, and this has got quite a nice diagram to go with it here. So attrition is when the rocks and pebbles from the cliffs, so that's already been broken down or fallen off the cliff face into the water, then rocks and pebbles collide with each other, and over time they'll break and become smoother. So you can see that two rocks being rubbed together, that's essentially what they're doing in the water, and they'll become rounder and smoother, as you can see on the second image there. The fourth one is solution. So solution is when there's acids in the seawater. So seawater is slightly acidic, and that water will then dissolve some of the rocks like chalk and limestone. So any rock that can be dissolved is dissolved in the seawater. So the image you can see there is just a sugar cube being dropped into water. So imagine that is chalk or limestone from the cliffs, and that over time will dissolve in the water and you'll no longer be able to see it. So this is just a quick summary diagram where you've got all the different types on one diagram. So you've got abrasion as number one. So the water's throwing the rocks at the cliffs and causing chips and cracks to form. Then you've got hydraulic action. So water is forced into the cracks and air is trapped, and that blasts out and forces the rocks and the cracks to become bigger. Number three is attrition. So that's rocks on the seabed that are continually colliding with each other, and they'll break and become smoother. And then finally, number four, you can't see it because once that rock is dissolved, it's invisible then. So solution is when the acids in the sea dissolve some of the rocks like chalk and limestone. So they're two examples of rocks that can be dissolved by the seawater. So different erosional processes affect how our coastlines look, and different erosional landforms are created. So we're just going to go through some of these quickly, and then next lesson we're going to go through some in more detail. So this is a wave cut notch, which you can see on the diagram. So it's the bottom of the cliff. So when the wave's at the bottom of the cliff, it erodes and this creates a wave cut notch. The cliff above the notch is undercut and it overhangs. So eventually this cliff here will no longer be supported because there'll be nothing underneath it because of this notch. And it'll eventually fall, and then it'll leave a steep face. So it's moving backwards and retreating the coastline. And then the process will just happen over and over again. So eventually another wave cut notch will form. The cliff will no longer be supported, and that will fall. So it's retreating back along the coastline. Here we've got what's called a wave cut platform. So as the cliff erodes, so this cliff eroding, this cliff would have once been here, and it's eroded, it leaves a flat rock and some rock pools as well. This is a headland. We've talked quite a lot about these, but remember a headland is made of hard rock, and then the bays are made of soft rock. So destructive waves will then erode the soft rock, and that'll create these bays, whereas this hard rock sticks out of the sea and forms a headland. So then you've got a bay. So remembering bays are soft rock, and here's your headlands that are formed because they're hard rock and therefore they take longer to erode. So this is a discordant coastline. So the bays are where the soft rock is, that's easily eroded to form a bay, and the headlands form where there's hard rock. So coastal landforms change over time, and one coastal landform that changes is a headland. So you've got a headland. This will erode and create a cave within the headland. Eventually the cave will go all the way through, erode all the way through, and create this arch. Once this arch here continues to erode, this will no longer be supported, and it will fall and create this, what's called a stack. And then eventually this stack will continue to be eroded and will create a stump as it falls. So this is your cave, just in a little bit more detail. The main process is hydraulic action that creates the cave. It's the water pushing the air into the cracks, and then the compression of the air causing the cracks to get bigger and the cave will break apart. Abrasion also happens here, so the waves throwing the rocks at the cliff face. Then you get the arch. So once the cave erodes all the way through, it'll form an arch. Once the arch falls, there would have once been an arch here between the headland and the stack. Once the arch is continue to be eroded, it will no longer be able to support itself, and therefore the arch will collapse. It'll leave a headland on one side and the stack on the other. And then over time, this stack will continue to be eroded and it'll fall and it'll leave a stump. Eventually the stump will continue to be eroded and you'll probably no longer be able to see it as it'll be submerged in the water. So here's a task for you to do. I've only put one task on this lesson because I think there's quite a lot of notes for you to make and diagrams for you to draw. But here I want you to sketch the headland diagram, and then on the next slide, when I turn it over in a second, you will see some statements, and what I want you to do is just match them as to where they should go in the boxes. So you can pause it here and then go on to the next slide when you're ready and continue the video onto the next page when you're ready, or you can just come back to it in a second, but I have got the answers on the video, so I don't want you to see them before you've had a go at it. So here are the statements. So yeah, just write them in the correct place from here. So draw your diagram out and then write the statements where you think they should go. You can even number them in order of the process that's happened, and that will just give you a diagram and an explanation of how caves, arches and stacks are formed. Okay, so there's your answers for you to check. Please try and have a go at it first before just checking your answers, and then you can tick them and make your corrections. If you've got a green pen, even better, you can use a green pen, but it really doesn't matter if you don't. Just use whatever you've got or a different colour or anything that you've got, it doesn't matter. But check your answers, make any corrections, and then can you please upload this to Show My Homework. So take a picture of your work and upload it, and then once you've done that, can you then go on to Show My Homework and complete the quiz that I'll have set you, and that'll give an indication to you and to us of how well you understood the content. So thank you for listening, and I'll be back with Coast Lesson 5 next week. Any issues, just send me a message on Show My Homework and I'll get back to you if I can, and if I can help you, then that's perfect. And don't forget, please, please, please submit your work if you can, and please do the quiz.